Hey there, Serena. So I realized what our thinking was. We were correct in matching the transformation, but not answering the question. So I'm going to quickly show you what we were looking at. So we started looking at the function negative 3 cos of pi on 6t plus 4, right? And that graph, you've got it over here already. And what we know is this is what it looks like, okay? And then we say, well, we can actually have it rewritten in another form where it is the negative of, yeah, because A is negative. So negative has to be the same amplitude and vertical translation. So it has to be plus 4 sine. And what's interesting, so the period still needs to be the same. So pi on 6. And the difference is that we know t. Usually the property is that cos of x is equivalent to the sine of x plus pi on 2. Okay, and that just means that you shift the graph to the left by pi on 2, right? So let's go to Desmos. Here's the example. So what you can see here is this is the cos graph. In fact, I should do it from 0 to infinity. So let's do 0 to infinity. All right, so 0 and then equals. All right, so this is what it usually, that's your cos graph, right? And then if I put in the sine graph, just the normal sine graph without any translations, okay, and I'll do the same thing, 0 to infinity. Okay, what we can see here is you're correct. The blue graph is the sine graph, right? Now, we can make this 3, 1 to match with this coordinate over here, which is 0, 1, right? Because the starting point of the cos graph is at 0, 1. So if you wanted to move it, well, you can move this to the left by 3. And to do that, yes, you're right. If we had x plus 3, that should work. So if I did x plus 3, well, sorry, I should put it in brackets, x plus 3, then it matches. And the reason for that is because it is a plus pi on 2. Because if you multiply pi on 6 to 3, pi on 6 times 3 does give you pi on 2, which fits in this definition, which meant we moved to the left by 90 degrees. Okay, so you're correct. There's nothing wrong with that. The problem is that your layout or the question said it had to be a minus. So I couldn't have a plus here. And that plus couldn't have been the possible. So I couldn't shift the graph. I'm just going to delete this again. You can't shift this graph to the left. You can only shift it to the right, is what the question's saying. So I'm going to take off the domain now. Let's take off the domain. And whoops, plus 40. All right. So you have to shift it to the right. That means where on this graph, and by the way, how did I know that point was 3 without looking at Desmos? Another way is that that's a quarter of a period. So you know sine graphs are broken up into quadrants. So that's the first quadrant. Next one's the second quadrant in the center. And the next quadrant, and then your fourth quadrant, right? So the first quadrant, you can find the period and divide it by 4. You know, it's a distance of 3. So the period, which you would have figured out beforehand, was 2 pi on 6, and you get 12. So that means quarter of a period would then mean that to go from one point to the other, this point to this point, that's a distance of 3. So we look at the question here, we can see that in order to move it to the right so that the bottom part or the bottom peak actually matches, notice here, that's the only other peak to shift the graph to the right. Because the easiest way is to shift it to the left, but since we have to move it to the right based on the equation, it says here you're moving to the right, then the smallest value moving to the right is, that's what, 1, 2, so that's a quarter there, that's 1 quarter, that's 1 quadrant, 2 quadrants, 3 quadrants, you're moving 3 quadrants to the right in order for you to get the negative 9, 1 here to the 0, 1. And so when we say 3 quarters, I'm talking about these points here. So this is 1 quadrant, This is 2 quadrants, 3 quadrants. I actually had to move. Can you see the graph was, where is it again? Let me just draw it a bit more carefully so you can see. Okay, and let's split it up. So this is 1, 2, okay. So our graph started like this. Now you can see you can either move 1 quarter of the period back to the left, okay, or you can move, now notice here that's 1 quarter, 2 quarters, and then 3 quarters. You can move 3 quarters to the right. Okay, so this is 1 quarter to the left. So 1 quarter of the period is what I mean. So 1 quarter of the period, and this is 3 quarters of the period. And since we know the period is 12, then that means 3 quarters of the period is then equal to 9. So that's why I know I have to shift to the right by 9, which is why that right there has to be a -9 rather than a +3. Now +3 does work. It's just that you're not answering the question, that you have to move to the right rather than to the left. So theoretically you were correct. Yes, they are a difference of pi on 2, but with the conditions that we had, we had to make sure we were moving to the right and not just to the left. That was the reasoning. Okay.